Thank you. Right, hold your applause till afterwards, and you can judge it. Right. Sorry for the late start. Okay, so this is a talk about modern Java, in which change is the only constant. In the last couple of years, we've changed the Java platform in 3 ways that we never have before. First, we took this massive monolithic platform that had grown monotonically over time, and we sliced it up into 26 standard modules. Second, we removed the Java EE and Corba modules and some other APIs, leaving us with 19 standard modules. And third, we left behind our historically grand and majestic but rather slow-moving and unpredictable release model in which we shipped a major release every 2 to 5 or, well, in one case even 7 years. We replaced it with a rapid cadence release model in which we ship a new feature release every 6 months on a strict time-based schedule. Now, modularizing the platform and removing submodules did break a few things. Many have wondered whether the Java ecosystem will be able to keep up with a 6-month release cadence. Taken together, all of these changes are, frankly, somewhat scary, but maybe not as scary as you think. Why did we make them? Because adapt or perish now as ever is nature's inexorable imperative, according to H.G. Wells. Or if you prefer a more modern formulation, adapt or die. So saith Andy Grove. We must change Java in new ways because its competitive environment is very different than it was 20 years ago. There have been 2 big changes. First, many popular platforms ship new features around once a year, if not every 6 months. If Java is to remain competitive, we must move it forward faster. Second, applications are packaged and deployed in different ways than they were 20 years ago, whether to the cloud or in packaged apps published to app stores. If Java is to remain competitive, then we must adapt it to these new environments. Let's take a look at the first big change, modularizing the platform. This is where we ended up. Nice, clean module graph, 26 standard modules, the Java base module at the bottom, perhaps the most important one. All other modules implicitly depend upon Java Base, and Java Base is the one module that depends upon no others. The JDK has these standard modules plus many more non-standard modules that contain development and debugging tools, service providers, and some JDK-specific APIs. This beautiful graph is not where we started. Where we started was with a spaghetti bowl of tightly coupled platform components with sometimes surprising interconnections. If you trace through all the dependencies here, if you wanted to print hello world, you actually needed Corba. Okay. Slicing all this up while maintaining as much compatibility as possible took years of painstaking refactoring and delicate surgery. We were finally able to deliver on that in JDK 9. Now, modularizing an old code base can be a ton of work, but modularizing the platform yielded many benefits. One benefit is that it's more flexible. A module names the modules upon which it depends, so the compiler and the runtime system can ensure the reliable configuration of consistent subsets of the platform. Most applications, after all, don't need all of these modules. If you have an application that only uses the Java SQL and Java base modules, you can link a custom runtime system that contains just those 2 modules, plus any other modules that they need. The rest simply fall away. Now realizing that the screen is somewhat distorted. Oh well. You can package this custom runtime system with your app, leading to smaller Docker images and smaller App Store packages that are tens of megabytes rather than hundreds. To take advantage of this, you don't need to modularize your app. You can do that if you want. There are many good reasons to do so, but it can be an awful lot of work, and frankly, if your app is in maintenance mode, then it's probably not worth the trouble. Another benefit of the modular platform is that it's more secure. A module exports specific packages for use only by the modules that depend upon it, so the compiler and the runtime system can enforce strong encapsulation. How much more secure is it? Of the 6 high-impact zero-day vulnerabilities reported since JDK 7 in 2011, 3 of them would have been prevented if we'd been able to strongly encapsulate the JDK's internal APIs. A final benefit of the modular platform is that it's easier to maintain. The JDK does have many internal APIs never meant to be used by external code. For decades, we've been warning people against using these. They've done that anyway, of course, sometimes in some extremely popular libraries. Now, to be fair, in some cases, these library developers were after critical functionality that was available in no other way. So, okay, fair play, that's fine. But in many cases, you know, we can all be lazy. We're developers after all. Why write your own base64 decoder when there's a perfectly good one over in the SunMISC package? For many years, we've therefore treated most internal APIs almost as if they were standard. We've been reluctant to change them because we don't want to break people's code. But this has made the platform harder to maintain and harder to evolve. With strong encapsulation, we can close off all access to the internal APIs of the JDK simply by not exporting the packages that contain them. If we did that right away, we would definitely break a lot of existing code. So we're taking a more gradual, nuanced approach, since migration takes time, especially in such a large ecosystem. Starting with JDK 9, and at least through JDK 11, if your code uses JDK internal APIs, then it will not compile, and it may generate warnings at runtime. By your code, I mean not just the code that you write, but all those glorious libraries you downloaded from Maven Central. Don't forget about those. We have deliberately relaxed the strong encapsulation of legacy JDK internal packages for now at runtime so that old code will continue to run. We will eventually strengthen the encapsulation of these packages once we've provided standard APIs for the critical internal APIs and once everyone has had a chance to fix their old code. When we do that, in some future release, code that uses JDK internal APIs will not run. In the meantime, here's an example of the kind of warning you might see if you haven't seen one of these already. This is a log of Jython, a Python interpreter written in Java running on JDK 9. You would see the exact same thing if it were running on 11, 12, or 13. It tells you an illegal reflective access operation has occurred. It identifies the code responsible and the internal API that it accessed. It suggests that you report this error to the maintainers of the errant library so that you can do your part to help move the ecosystem forward. It tells you how to get additional warnings if you want to see them, because by default only the first such warning will be shown. And of course, there might be hundreds or even thousands, who knows. And finally, it reminds you that all illegal access operations will be denied in a future release. To help you get ready for that future, when such code will not run, we introduced a new tool in JDK 9 called JDEPS. If you run JDEPS against an existing jar file with the JDK internals option, it can detect most uses of internal APIs. As an example, here it detected the use of sun.security.x509.x500 name, very popular class. It is an internal API. It even suggested a standard replacement. And note that the @since 1.4. When did Java 1.4 ship? Anybody know?
2006.
2006? No, further. 2002, 17 years ago. There's really no excuse not to be using the standard API here. Anyway, JDEPS, recommend that you use it. The modular platform does break some things, but it doesn't break everything. In fact, if your code uses only standard Java SE APIs, then it most likely will work without change. I say most likely because there are some very minor differences. We removed a few obscure, rarely used methods and mechanisms to enable that clean modularization. We also made a few behavioral changes that honor the specification, but in rare cases might break existing code. If you want to know more, have a look at JEP 261, which lays out all the compatibility-related changes in great, gory detail. Beyond that, to learn more about Java modules and the modular platform, I can recommend all three of these excellent books. So the modular platform enabled the second big change of the past year. We've reduced the platform by actually removing things for the first time in Java's history. Well, at least the first time on purpose. We removed the Java EE and Corba modules in Java 11. Why? Well, the details are in JEP 320, but in a nutshell, these components are costly to maintain. They've been the source of multiple security vulnerabilities over the years, and nowadays they're either available elsewhere, as in the case of Java EE, which is now at Eclipse and is called Jakarta EE, or they're no longer relevant, as in the case of Corba. We removed some other smaller things too. As I mentioned, in order to modularize the platform cleanly, we removed some fairly obscure methods in Java 9. Most of these had to do with configuring property change listeners on various core APIs. These methods probably never should have been added in the first place. They were sort of an abstraction, boundary violation, putting AWT methods in core classes. Really? Okay, but there they were. We removed these only after analyzing a lot of code out in the wild to see if anyone was using them, and hardly anyone was. While we were at it, we also removed a pointless constructor that somehow accidentally snuck into Java 8. We removed more methods in Java 10. All of these methods are ill-defined, actively harmful, don't work, or don't do anything useful. We removed yet more such methods and one class in Java 11. Removing things can cause breakage. To ease the pain, we always give advance notice by deprecating APIs to be removed at least one release in advance, and often more. As an example of that advance notice, here are all the APIs deprecated in Java 11 for removal in a future release. If you look closely, you'll see that this list mentions many finalize methods in the core APIs, which we're removing because finalization is a fundamentally broken mechanism that we've replaced with something better. When an API is deprecated for removal, that's always noted in the API's Java doc. For example, here's a method. This is a very old method, goes all the way back to Java pre-1.0, back when we only had bytecode interpreters. We didn't have JITs that compiled. This is about tracing method calls. You read the deprecation notice, intended to control method call tracing has been superseded by JVM-specific tracing mechanisms. Note the subtle and sophisticated specification not implemented does nothing. Nobody's going to miss this. If you compile source code that uses an API that's deprecated for removal, then the compiler will helpfully warn you about it. All right, popping up. First, we modularized the platform, and then we trimmed it down, and then we started moving it forward at a faster pace with a new release every 6 months. How can that possibly work? Let's look at the timeline. We shipped JDK 9 in September 2017. We shipped 10 just over a year ago in March 2018. We shipped 11 last September and 12 just 6 weeks ago, this past March. We'll ship JDK 13 in September of this year, and so on every 6 months, like clockwork. Now, one of these feature releases can contain any kind of feature, a language feature, a VM feature, a performance feature, a library feature. It can even remove an old feature. For this to work, features can only go in when they're nearly finished, because we can no longer slip a release in order to fix a broken feature, something that we did all too often in the past, frankly. But that's okay, because if a feature misses the current release, the next one is just 6 months away. It's no big deal. At the beginning of all this was JDK 9, the final massive JDK release. There were 90 JEPs in JDK 9. We shipped it 3 years and 6 months after JDK 8, which had shipped in 2014. There were 2 major slips to the schedule, and both of them were my fault. Oracle engineers did much of this work, but not all of it. 6 JEPs came from outside Oracle by contributors from Red Hat, Linaro, and SAP, plus 2 independents, Doug Lee and Laurent Borges. These non-Oracle contributions were significant. They included 3 CPU ports, some important performance work, and a brand new 2D graphics rasterizer. So after all this, what was going to be in JDK 10? One worry we actually had about the 6-month cadence was there might be 0 features in a release. It's theoretically possible after all. If you're going to ship like clockwork, then every 6 months you ship what you've got, and maybe we could ship a release that just has some bug fixes and small enhancements in it rather than any bigger features. Happily, that turned out not to be the case. JDK 10 contained 12 JEPs, including 1 language feature, local variable type inference, some more performance work, a massive refactoring of the source code into a single Mercurial repository. Again, Oracle engineers did much of this work, but 2 JEPs came from other contributors. JEP 304 was a GC interface built by Roman Kenki at Red Hat. And JEP 316 from some engineers at Intel. They implemented heap allocation on alternative memory devices. This pattern continued with JDK 11, which contains 17 JEPs, including some long-needed JVM improvements, a new HTTP client API, The ability to launch single-file source code programs, which many people laugh at first, but it turns out to be really, really useful. And also TLS 1.3, just in time for the final Internet standard. Oracle engineers did, again, do most of this work, but 3GEPs were contributed by others. From Belsoft and Cavium, we got some ARM64 performance improvements. Alexei Shiplev at Red Hat contributed the Epsilon garbage collector, which isn't really a garbage collector because it never collects anything, but that's sometimes useful for benchmarks. And John-Christoph Weiler at Google contributed low overhead heap profiling. Moving on to JDK 12, there were 8 JEPs, including a micro benchmark suite for the JDK itself, a preview language feature, switch expressions, and various VM performance improvements. Oracle, yes, did most of this work, but in JDK 12, we do have an entire new garbage collector, Shenandoah, contributed by engineers at Red Hat. As you can see, I hope, what has changed here is not the rate of innovation, but the rate of innovation delivery. In 3 years, by 2021 or so, we probably will have merged around 90 JEPs, just as we had in JDK 9. Now, these feature releases aren't just about JEPs, of course. Each contains many smaller enhancements and bug fixes. As an example, according to our bug database, we resolved almost 2,500 issues in JDK 11. Oracle engineers worked on most of these, but there were significant contributions from others, including engineers at SAP, Red Hat, Google, a bunch of individuals, and Belsoft. Returning to our timeline then. The 6-month cadence will enable Java better to compete with other platforms. But you might be wondering, what about updates, security fixes, critical patches? The plan in the OpenJDK community is to update the current feature release for at least 6 months. That's 2 quarterly update releases. And then every 3 years, we'll declare a long-term support release. The first being 11, which shipped last September, the next being 17 in 2021. If you like, you can think of JDK 8 sitting way up there, being the previous long-term support release. Each of these long-term support releases will be updated well past the beginning of the next LTS release, and possibly even longer. You might think that the non-LTS releases are in some way experimental. Oh, they're just a fancy name for a beta, I've heard some people say. But they're not. Every release is production ready. What differs is only the length of the support timeline. So, you have a new kind of choice to make. You can take the blue pill or the red pill. You take the blue pill, you wake up in your bed and continue to develop and deploy uncomfortable, conservatively managed, slow-moving LTS releases with an update release every quarter and a major migration every 3 years. You take the red pill and you go down the rabbit hole, where you can enjoy the latest language features, API enhancements, performance improvements, and bug fixes with a minor migration every 6 months. It's up to you. All I offer is the truth. If you do choose the LTS path and take the blue pill, you might be wondering, who will produce your update releases? Again, you have a choice to make. Since JDK 9, Oracle contributors in the OpenJDK community have focused and will continue to focus primarily on feature releases rather than on updates. Oracle will ship OpenJDK builds under the GPL for the first 6 months of each feature release. That's the GA plus 2 updates, whether that release is a long-term support release or not. After that, Oracle will offer long-term support builds, but in a change from the past, these will be available only under a commercial license that allows free use for development and testing, but requires payment for use in production. That might sound scary, but don't worry. Java is still free. All of the code is still available under the GPL for anyone to build, test, publish, update, and support. Oracle engineers won't regularly contribute to, much less lead, the LTS releases as they have in the past. But that's okay. The OpenJDK community as a whole has a proven track record of transitioning the leadership of update releases from Oracle engineers to non-Oracle engineers. We did that years ago for JDK 6 and JDK 7. We did it again for JDK 8 and JDK 11 earlier this year when Andrew Haley, Red Hat's Java platform lead, took on the leadership of the JDK 8 and JDK 11 updates projects. And this isn't just my personal fantasy. As Andrew has assured everyone, Whether by Oracle or Red Hat or someone else, JDK LTS releases will continue to be supported. We all have a lot invested in Java, and we won't let it fall. The LTS work will carry on in the OpenJDK community as it has in the past. You'll be able to get carefully built, well-tested JDK LTS builds based upon that source code in any Linux distribution, whether derived from Red Hat, Debian, Gentoo, or Arch. If you're not on Linux, you'll be able to get LTS builds for free from a variety of providers. For this plan to work, it's critical that you be able to switch from one provider to another. In past release, this wasn't quite possible since Oracle always held back a few so-called commercial features that were only available to paying customers. These included application class data sharing, Java Flight Recorder, Java Mission Control, and the Z garbage collector. To enable such switching and to establish a level playing field for all, over the past 2 years, Oracle open-sourced these commercial features so that Oracle builds and OpenJDK builds are functionally interchangeable. You can switch from one provider to another as you please. When you choose a provider, though, you might want to consider those with the depth of knowledge that comes only from a long-term commitment to the platform. You have a choice. You take the blue pill or the red pill. You can choose the conservative LTS path and take the blue pill with a major migration every 3 years. That can be a good choice for a conventional enterprise-style deployment of large applications on large servers. Or you can choose the fast-moving feature release path and take the red pill with a small migration every 6 months. That can be a good choice if you're deploying to the cloud or to app stores and you're bundling the JRE or the subset of Java that you need with your app. If you choose the LTS path and take the blue pill, then you shouldn't ignore the non-LTS releases. Some free advice. If you maintain an infrequently migrated system, then you should still test it with each non-LTS release. That way you'll be nearly ready for the next LTS release by the time it's available. You're essentially spreading your migration effort out over time. If, on the other hand, you choose the adventurous feature release path and take the red pill, then you're going to migrate to each feature release as it becomes available. So make sure that your tools and dependencies can keep up. Many will be able to keep up, but some won't, especially if they're unmaintained, so plan with care. To sum up, we are evolving the Java platform at a more rapid pace in order to keep up with competing platforms. We have broken a few things and will continue to do so in order to make Java a better fit for modern applications. Are these changes really all that scary? I don't think they are, for 4 reasons. First, we'll always give advance notice before removing anything, and we'll only do so when there's a very good reason, because we don't want to break existing code unnecessarily. Compatibility remains one of the core values of the Java platform. Second, you have a choice to make, which you didn't have before. You can take the blue pill and migrate every 3 years at a comfortable stately pace, or you can take the red pill and enjoy the latest features and fixes every 6 months. Third, it's true that Oracle will no longer provide free update releases, but Java is still free. Free updates will be available from a variety of other providers, including all of the major Linux distributions. If you want active support, then you're probably going to have to pay someone or do it yourself, but that's always been the case. So choose your provider wisely. Finally, we did break a few things. Migrating past Java 8 may require some work, but it might not be as hard as you think. All 3 of the major IDEs already support all of the new language features, even the ones in 12. Many popular tools, libraries, and frameworks already support JDK 9, if not 11 or even 12. You don't have to take my word on this. Just after Java 9 was released, some of you might recall this, I asked on Twitter, do you maintain a popular Java library, framework, or tool? If it works fine on JDK 9, then please reply with its name and version. That was way back in 2017, ancient history at this point. So shortly after JDK 11 was released last fall, I asked, do you maintain a popular Java library, framework, or tool? If it works like heaven on JDK 11, then please reply with its name and version. My thanks to Sam Brannon of the JUnit team for the hashtag. I saw many, many responses. All 93 of these libraries, frameworks, and tools work just fine on JDK 9. They worked without change, or their maintainers fixed them, and in many cases, it wasn't that hard. These include the build tools, Ant, Maven, and Gradle, test frameworks, JUnit, TestNG, popular libraries, ByteBuddy, Jackson, Log4j, Hibernate, Juke, Netty. The entire Spring framework is here. 51 of these components work not just fine on JDK 9, but like heaven on 11. Since the transition from 9 to 11 is much easier than the transition from 8 to 9, I expect the rest of them will catch up in short order. Maybe they already have. My most urgent advice to you today, then, is this. If you're using Java 9 or later, upgrade to the latest versions of all your tools and dependencies, because everything changes and nothing stands still. So, at this point, I was going to show some demos of features that we've shipped recently, of features that are in the pipeline. It's actually a really exciting time in Java right now because our feature pipeline is the richest and fullest that it's been in years. We've got some really exciting stuff in the works with Project Loom and Fibers, Valhalla, and value types. Unfortunately, here at CERN, with all of the wonderful technology, it is unable to talk to the machine upon which I do the demos. So, for the remainder of the time, I would be happy to take questions from the audience if you have any questions. If not, I'll sing and dance, but you don't want to see that. Do we have a microphone we can use?
So, in fact, you all have a microphone. There's a little button in front of you.
Ooh.
And if you press the button, then we can hear you when you're speaking. This is a place for voting in large council matters, so everyone gets a microphone. Any questions?
Raise your hand so I can see you. Yep. Yes, sir. Can you use is the mic on?
What do you think of Amazon Corretto?
Amazon Corretto, it's another distribution of OpenJDK. It appears to be popular. If it solves your problems, use it. You know, I personally haven't run it. I don't know if it's really good or really bad. I know some of the people who work on it. You know, they've got some good engineers working on it. So, might be good, might not. Like anything else, just like builds from Oracle. Well, the final test is what you see when you run it, and the support that you get when you have a problem. But in general, my view is the more the merrier, right? Yes, sir.
I would like to ask you if there is anything planned for delivering standalone applications, like you had Java Web Start, which was killed, applets, which were killed. Is there anything planned in newer versions for doing similar job?
Standalone applications, yeah. So applets were killed, not our fault. Blame the browsers. Java Web Start, yeah, that was deprecated and removed pretty quickly there. Standalone applications. If you mean standalone applications on PCs and on Macs, I think the future is applications that are delivered in a native, the proper native fashion for those environments. Just as in an app store, you can really only deliver something in whatever format or formats the App Store supports. The best way to deliver an application to Mac OS or Windows is to have your application contain the JVM or the subset of the Java runtime that it needs. You don't need all those modules, remember. And package that up into one artifact that you can then deliver, and that's installed by the user in the normal way. In fact, the user shouldn't even know that it's a Java application as opposed to any other application installed on that machine. So the future is, I think, is essentially up to a tool currently in development called the Java Packager. There's a JEP for this. I don't remember the name offhand. But it's in active development. There are early access builds available on jdk.java.net. You can download it and play with it and send us comments if you have any, please. Java Packager is essentially, it's a front end to JLink, which is a lower level tool that's built on the module system. JLink is the tool that allows you to take a subset of the modules and build a very small JRE, possibly containing modules from your application. JPackage is a tool that builds on top of that, so not only will it make a small JRE for you, but it will take other bits of your application that you need and package them up into an OS-specific format. So it will make a Windows installer for Windows. It'll make a DMG or whatever for Mac OS. Whether we do anything for Linux, I think, is still up in the air. But JPackage is the future there. The future very much does not include anymore the notion of a shared JRE in the system, at least on Mac OS on Windows and Windows. It does on Linux because Linux does a much better job in general of managing OS package dependencies, and so you can count on that. Yes, sir.
So here at CERN we have a lot of desktop applications, so I take a bit also the question from my previous colleague. In particular, what are your advices for users that have a high dependency on Java Swing and then JavaFX technology? How will that, in which direction shall we be prepared to evolve?
So Oracle is no longer investing as heavily in JavaFX as it once did. That could change. Anything can change. JavaFX is still very much a going concern. Johan Voss and others have gotten quite a few good people together working on JavaFX and continuing to fix bugs and enhance it. So it's still there, and I think it's still viable. Swing is not. I don't think it's going to go away. I don't see how it can go away. Now, as in all matters, I do not speak for Oracle, but I would still be shocked if Swing ever went away. It has not seen, frankly, much enhancement in the last few years, other than I think high DPI mode and a few other minor things. It's a pretty mature graphical user interface toolkit, and it's used in lots of important places like here. So, I doubt that will fade anytime soon.
Could you position GraalVM against WebAssembly?
Could I position GraalVM against WebAssembly?
They seem to be competing.
That's not a question I would have guessed. GraalVM against. So, which aspect of is there a particular aspect of GraalVM that you mean? Do you have in mind?
No, generally, what do you see in the future? How will they compete with each other? Because I see that WebAssembly started to be a VM inside the browser, but now they try to position it as a general VM, and Java was in the browser.
Right.
Let's not talk about that, but with GraalVM, it's a very mature VM, and WebAssembly is a very new one and very lightweight, and they try to. I see that they try to bite into the part of the area where GraalVM or GVM can work and run and execute applications. And competition generally is not a problem, but I would like to see your point if you have any about this.
This is a fascinating pair of items you've asked me to compare. I feel like I'm taking one of the academic SAT tests or something. This is to that as that is to this other thing, and what? But I'm probably just missing your point. So let me just riff a little bit on these two things. WebAssembly. How many people watched Battlestar Galactica? All of this has happened before. All of this will happen again. I have to say it's more than a little bit entertaining to watch WebAssembly because it's Java bytecodes all over again. right? A different format, but essentially the same idea. Not that Java bytecodes were a new idea. I mean, there had been architecture-independent distribution formats, going back to the 60s. But yeah, all of this, we're just going around the cycle. So WebAssembly, yeah, it's interesting to watch. They've got starting to get some interesting performance numbers. Sandboxing in browsers, been there, done that. It's really hard. There are some difficult lessons ahead. I don't know how to compare it to GraalVM or Java in general, except to say, well, it's another architecture independent target. One could imagine a tool that would translate Java bytecodes into WebAssembly, say. I expect 3 such things to show up on GitHub within the next 2 years if they haven't already, because it'd be a cool hack. Would it be useful? I don't know. So yeah, I don't really know where WebAssembly is going. I wish them luck. There are some domains in which it looks like it could be pretty useful. Is it competing with Java? I'm frankly not sure at this point. Maybe it will. Especially recently, there has been some motion to start using WebAssembly outside the browser, and well, maybe that whatever that turns out to be could compete with Java one day. Who knows? GraalVM. So GraalVM has been a source of confusion. GraalVM is not it's never going to show up in browsers, so there's no competition there. GraalVM is got a bunch of interesting technology in it. The 2 main interesting things are it's got deep support for multiple languages. So you can run Java code, Python code, R code, Ruby code, JavaScript, all in the same process, all in the same VM with very efficient connections across language boundaries. And that's really cool and sometimes really useful in certain kinds of applications. The other thing that GraalVM contains is a system called the Substrate VM, which is a little bit of a confusing name because it's not a VM actually. So Substrate VM is a tool that can take your Java application, your whole class path and the JDK that you've got. It does a bunch of static analysis and condenses that down into precompiled native code. So the result doesn't have there's no Java virtual machine in it. It can't interpret bytecodes. It does have a garbage collector, of course, but it's also missing anything that it couldn't figure out that your program needed. And of course, since since things like reflection are heavily used in Java, it might have missed some stuff that your program actually does need. So it's a bit of a difficult tool to use because you usually wind up having to tell it through a big configuration file. All the APIs that you're going to access reflectively, please include these because I'm going to need them, because otherwise it would strip them out. The cool thing about Substrate VM is it produces native images that typically start up very, very quickly and are typically very small. So, for some kinds of applications, if you're, into all the buzzwords, microservices, functions as a service, small functions shipping around, competing with things that like, Go can do, that Substrate VM is pretty interesting. But, it's still early. It's not, it's essentially experimental still. Lots of people are kicking the tires, which is great. But I think before it gets wide adoption, it needs to be more broadly used. I guess the third major, our 3 major features in GraalVM. GraalVM also includes the Graal JIT compiler. And there is a copy of the Graal JIT compiler in the JDK now. We hope eventually to replace our old compiler, runtime compiler C2 with that. There's a newer and fancier version in GraalVM, and if you get GraalVM EE, then it has even more optimizations in it. So we've seen that on common workloads, there could be a significant performance boost from that. You mentioned GraalVM being mature. Parts of it are mature and parts of it aren't. As a whole, it's not as mature as the JDK. And WebAssembly, of course, is practically a newborn as far as these things go. So I don't know if I answered your question, but hopefully that was useful or at least entertaining.
Yes, thank you very much.
Sure. Yeah.
I was thinking sometimes you have actually two products for me interesting. One is JVM, one is Java. And sometimes I think, wouldn't it be, let's say, make sense to separate them? For instance, why? Because sometimes, of course, they are dependent on each other, but sometimes let's imagine I have a product that works on JVM 11, long term, and then I have a module that I would like to use the features of a new Java version. And now I don't have a way to compile new source code against old JVM bytecode, which, for instance, other JVM languages sometimes do. Like Kotlin, you can compile against Java 8, Java 6, of course, there are some limitations. Wouldn't it make sense to somehow separate those things?
So that you would have different products?
Yes,
yeah. Okay.
In fact.
So sorry, I'm seeing a conceptual type error here, actually a couple of them. One is JVM by itself is useless, because you need all the class libraries that make up the whole system. So I think you're really talking about the JDK.
Yeah, okay. Yeah.
The JDK, a JDK, is a pile of bits, has a bunch of stuff in it. We all know roughly its shape. Java is not something that you can run, right? There's this dichotomy here. Java is the Java platform. The only form in which you can download it is you get a specification. You get a ton of Java doc, you get the Java language specification, the Java VM specification. Java's this abstract thing, and then the JDK is the shadow on Plato's cave wall. That's the actual bits that you can execute. The JDK, in the parlance of the Java community process, is the reference implementation for the Java platform. Both evolve at the same time, deeply synchronized, and we have the Java compatibility kit, the suite of hundreds of thousands of compatibility tests that validate that the reference implementation meets the specification. So having Java be a separate thing is not something I think that could ever make sense. To the particular issue of compiling against older versions, there is the capability and has been in the Java C compiler for quite a while now to specify an older release. So you can say Java C -- release 8, and you can do that, I'm pretty sure,
with new code
in JDK 12. And
then it says mostly the source and target must match, as far as I remember.
Sorry?
As far as I remember, it always complains that the source and release basically must match. So I cannot use, I think, as last time I tried, I cannot use new language features against old JVM platform.
Right. Well, so in general, you're not going to be able to use new language features on old JVMs because the entire system evolves in synchrony. New language features often mean new JVM features, new bytecodes. New changes to the class file formats. So there's only so much we could do. We could stop investing in the future of Java and invest in this kind of being able to compile new code for older platforms, but I don't think that would be the best. Okay, sorry.
Okay.
Can we move on? Time's running short. I'd like to take at least one more. Whose hand has been up the longest? Be honest now. Sir.
Quick question. Do you think we get ever released from the burden of checked exceptions, or this is something that is untouchable for the foreseeable future because it would break things?
Checked exceptions. Well, at least you didn't ask about serialization. Checked exceptions are a tough one. We've spent a lot of time thinking about checked exceptions. My personal view is that if we were designing Java today, we wouldn't have them. But we do have them, so we need to make the best of them. I think in the history of language design, checked exception... Whoops, there goes an unchecked exception right now. Checked exceptions as a language feature were a minor mistake. The bigger mistake was the abuse of checked exceptions in many parts of the platform where they really weren't necessary, right? Amy, whoever did the XML APIs, why did it have to be a checked exception if you couldn't instantiate the XML parser? I mean, come on. You've got an XML API. There must be an XML parser in there. why do I have to catch this stupid factory exception thing and deal with it? It was just, yeah. So, I mean, I suspect, and I think it would be an interesting exercise to go through all the checked exceptions and figure out which ones really need to be checked. It turns out it's actually a binary compatible change to turn a checked exception into an unchecked exception. So someday we might do that. One more minute. Quickie. Quick?
Hello. Is there some date for Java Fibers?
Is there a date for Java Fibers? So the great thing about the 6-month, one of the many great things about the 6-month cadence is it makes it really easy to answer those annoying questions from management. When is feature X going to ship? Is feature X going to ship this year? Is it going to ship next year? What release number is it going to be in? And the answer is, I don't know. We're going to ship it when it's ready, just like the rules say. Every 6 months, you ship what's ready, and you don't ship anything until it's ready. Fibers are moving along quite nicely. I wish I had been able to show you the demo today. You know, random guess, are they 10 years out? Certainly not. Are they 5 years out? Probably not. Are they going to be in 13? Certainly not. You know, interpolate from there. You know, sometime in the next few releases is my best guess. Sorry, one more thing I must do to satisfy my employment contract. Don't believe a word I've said. Thank you very much.